So thanks everyone for staying up until this late today. Uh, this is a talk that has been a first time for different things. Like it's the first time at SFSCon, and it's the first time I have more than 8 minutes to present this work, which is great. Thanks a lot for the organizers. And this is also the first time I present this as a Mozilla AI project. I started this on my own. I presented it as a personal project in FOSDEM in February at the Fediverse track. And it got good reception. At work, they were super supportive about that. They suggested it to promote it into a Mozilla AI blueprint, and then they kind of sponsored me along the way. So it's something I can do not just in the weekend now. It's not a product. It's not something we're selling. I'm also telling you about what it is right now. But again, this is the main reason why you see Mozilla AI in the top right corner of every slide over here. So what is Biota, Build Your Own Timeline Algorithm? It's a call for arms, in my opinion. We have heard already about taking the tools in our hands, owning them, trying and change the status quo about how things work. And for me, Biota is all of this. It's not an application. It's kind of an application too, but it's not something that is just there to be used by users. There's no real users. For me, it's more like a tool that builders can use as an example to see what they can do with the timeline algorithm or with an algorithm that you can use for your timeline that you also own. That allows people to run something different without sharing their own data, without connecting to any external service, and so on. So there is a little bit of story about how this started, and probably some of you know this kind of plot. This is how people moved outside of Twitter. And the dates over here, dates over here correspond to when Musk purchased Twitter. This was also kind of simultaneous to me leaving the company because I was working there. And just so you know, the work started before that. It was something I did not just out of spite. I actually used the previous interaction with Musk when he said, I want to buy Twitter, as an excuse to start learning what the Fediverse was. And I registered my account then, a little bit before the other folks, and a lot time after a lot of other folks. And I enjoyed the community so much that I said, I really need to do something that I feel can contribute to this. I was working on algorithms, on machine learning. It was not called AI a lot at the time. And so I said, let's just start and try and do something with all this stuff. And it took me a while. Like, this was 2022. Now it's 2025. The right tools were just not there yet, at least at the moment, I believe. So before talking about the tools, I want to tell you a little more about timeline algorithms. So basically, they are those algorithms which define whether something appears in your timeline or not, and also how this appears, in which order, whether it's emphasized or not, and so on. And these are a few that I noted down. There are plenty of them. There are custom ones. These come kind of from the literature. And as you can see, the first one is reverse chronological. I wanted to add this too because it's an algorithm. And it's also biased to some extent, meaning that the people who write the most are read more by myself. And the people who write in my time zone are read more by myself because when I sleep, I don't read those posts, and I don't spend all my time to scrolling until I finish all the new posts since the last one I read before. So I wanted to find kind of a solution to this, which is not a solution that everyone has to revert to. Like, everyone can choose however they want to use this. But I felt like I wanted for people to have a chance to find stuff they might have been interested in without having to just doom scroll until they found it. And of course, there are methods. There are hashtags, there are groups of people, there's a lot of things. I wanted to add mine. This is a general description about how timeline algorithms work. It's by Luke Thorburn, and there's a blog post which explains perfectly how this works. And I will just point you to that because I believe it's super useful. Just at a very high level, you have a first filter here, which is moderation, that we also have, and we don't need an algorithm right now for that. There's candidate generation, which basically filters things which are most likely to be liked by you. And then there's ranking and re-ranking, which basically changes the order of the posts that might be more relevant for you. This kind of characterizes many of the algorithms you find around. And this instead is a set of different approaches that I found people were using already on the Fediverse when I started, let's say, doing my homework and trying to understand what had been developed, what was the reception by people, and that was so useful for me. I really wanted to do things right. I didn't want to just say, hey, I came out with this new technology and now everyone is tracked. So I'm really standing on the shoulder of giants here. These were people who did something that allowed me to learn how to make my own work. While studying all these algorithms and all these approaches, I found there was a set of problems that was not common to all of them. Some of them had a few, some others didn't have all, but each of them had at least a few of these. So being biased, even reverse chronological has it. They can be not transparent, not giving control to users. Most of them are definitely not privacy preserving. They have huge computational costs, at least people think so. They require deep machine learning knowledge, and they cannot be run locally. But I just decided to question this and deconstruct everything and say, isn't there a chance to do things differently and to have something that we really own and that doesn't have all these issues? So we can have some models which are open, inspectable. We can have models that we can change, so we don't need to buy a given tool or another. We can just swap them around. We can have something that runs locally. We can have something that runs on low-power hardware. We don't need to train a huge model to solve this problem, which was very, very silly. And just so you know, if it ever happened to you to work for a big tech company, especially centralized social network, probably never going to happen. But one of the things they ask you is, I want to do this faster. I want to do this more cheaply. And some of those approaches are really approaches that you could run on your own computer because you don't need to parse across 1 billion messages. You need to parse across your timeline, which in many cases is just 100 posts that you can download from the API. So that's it. So enter Biota. Biota is a mix of different softwares, 3. Not a lot. And none of them has been written by myself. I just put them together. So there's the Mastodon API. It's a Python API, a Python library that allows you to get posts from Mastodon. And it takes care of authenticating you, getting messages from your different timelines. Then there is, on the other side, Llama-File, which is one of many softwares to serve a large language model, but even smaller language model, locally, if you want. And then there's Marimo, which is the one you see at the center, which is basically some kind of interactive notebook that you can play with inside your browser. Just for you to have a bit more detail about these, Llama-File has one characteristic that other tools don't have. It's a single file, polyglot, self-contained, executable, which means that you just download one file and you have a model that runs on your computer, regardless of the fact that you're running Linux or Windows or Mac, ARM, x86, whatever. It's just going to run. And you can use it to serve a plethora of different models, from old small BERT encoders to the most recent GPT-OSS. It doesn't matter how many parameters you use. But the one I chose is this all-mini LM, which is a tiny model. It's really, really small, and you will see the details later. It's something that runs on a Raspberry Pi easily in real time. There's code, papers, and training data for this model, which is the reason why I chose it. Everything is kind of replicable here. And it's completely local, optimized to run on slower hardware, and it will run almost forever, also because the nature of the files that it's built into allows it to run on a different operating system too. So let's say you change operating system, you just take it and move it around, and it will still work. There's also some news here that we recently tried to revamp Llama-File, so it might also have support for more recent models in the future. And I think this could be good news because I don't know a model that has Welsh support, for instance, for languages. It would be interesting if somebody works on that. It might be supported already. Marimo is a notebook, a Python notebook. It's reactive, which means that you can change any part of the code and it immediately will show you the differences there. And it has a nice UI, and you can also remove immediately all the code and just use it as an application, as a web application. It can also run on WASM, which means that anyone with a browser can open the software and run it locally on their computer. So this is the interface you get from Marimo, and there's part of code, part of images, but you can also just take away all the code in the app mode and see only the part that's an application. Or you could move around different pieces of this application and just have your own panel with just the widgets that you're interested in. I found it very nice as a kind of UI for people. What can you do with this tool? First one is embeddings visualization, which is for me a way to understand whether the approach works. What is an embedding? Embedding is a descriptor, a mathematical descriptor, a string of numbers that describes a piece of content, in this case a single post that you have downloaded from your timeline. And it describes it in a way that posts which are similar are points which are close in this kind of space. I represented it as 2D, it's multidimensional, we don't care. We can plot it, and visualization here allows you to see your post, in this case it's my local timeline. You can get the home timeline, you can get the federated timeline, you can get stuff that you search with a given hashtag. You can also plot everything together. And this is an example of something that merges timelines from different accounts that I have on different instances, and you can see stuff close together if they talk about the same stuff. So this is people united by word series in this area. This is people united by information about flights, airplanes. This is reading everything about books. This is Halloween, I did it last week. And this is languages, people united by not speaking English. So everything which was not English falls here. It's a limit of this model, and you can see it immediately, which I believe is very useful for people who want to build an application with that. This is well, it took me a lot of time. I just took the timelines I had. I tried to describe what happens where in this 2D representation, just to give you an idea about how you can group together different posts. The fact that you can group together these posts just by their distance tells you that you can do other things with this post. 2 points which are similar are talking about the same stuff, like family and parenting. I don't know why it felt close to not safe for work stuff, but that's another thing. Also, I always specify these are red. They're not my personal timeline. It's like the server timeline. So I don't follow directly those things. And you can do semantic search. You can provide a string, and you can find all the posts that are related to what you wrote in this string. You can do re-ranking, and there's just a lot of widgets showing you how this works, but the main idea is that you can provide a set of posts. These are my posts, and you can end up with a timeline that is re-ranked depending on what you wrote, or what you liked, or what you boosted, or it's something that comes from a tag. This is tag bouldering, and I'm using this to re-rank my own posts to show you the posts that I wrote that are mostly related to bouldering. And you can do it, apply it to any other timeline, even ones that are not there. And I know I'm short on time, so I'm going to skip the re-ranking, and I'm going to tell you in terms of how it works. Is it too good to be true? It runs relatively fast. These were the stats from February. These are the stats from now. New versions came out. We can embed or encode 800 posts in 4 seconds on my laptop. It's going to be a bit slower on my 2016 laptop. It's fine. It runs on a Raspberry Pi, by the way. This is local software. Again, this is what happens when you call the tool. You download the libraries that you need, and then you download posts from Mastodon, and then you just start calculating embeddings on your local computer. What is next? This is a tool that I built on Blue Sky, re-ranking, actually creating my own timeline just by providing a string saying that was for the gay pride, and I said, please provide me something that is related to this, and I got a personalized timeline for that. You can get to the other conclusions here. The time is short. Sorry for not having time for questions.
So thank you, Davide.